partial fractions, you should also look at the integration which includes the inverses, right? Trig inverse. So what we're going to be doing first, I think we can start with this one of partial fraction. Then we come to the inverse, trig inverse. So now I've included each part. I've included definitions and properties and also worked examples, right? So as I said, we're gonna start with the partial fractions. So with the partial fractions, I just included the part of definitions and properties just for those who are interested in extra knowledge, right? But for us, we're just gonna focus on the worked examples. Then we use what you've been taught in order to find the solutions, right? So yeah, so for now, I just included some of the information which you guys usually don't look at these topics in this manner, but I just included them in this way so that you can have some idea. Those who are interested in knowing what's really happening here, they can look at some extra information. But we're gonna stick to the one which is in your guide. So sticking to such an information, coming to the first problem, guys, if we can see here, we're given this problem. They say that we have the integral of 1 over x, x plus 1x. So I'm just gonna open a new slide, and then we're gonna discuss them, right? Let me see if I have a slide for. That's fine. I think I can use the one for SMTH, right? 0 and 1. So yeah, so when we come to that problem which we were given, the first problem that we're assessed with is the integral of 1 over x plus 1 dx, right? So first thing which you do when you're given a problem like this, you should ask yourself this question: is the degree of the, here's how you apply the first question that you ask yourself, right? Let's say this is the degree of the denominator greater than the degree of the numerator. This is the first question that you're gonna ask yourself, right? Then we're gonna go back to the notes. Let's go back to the notes. Then we look at the first part, which I said that I just included for extra information. So when we look at this part, we are always going to be given a function in this manner: p of x over q of x. So we can just go here, label this. We see that this is in this format. This is in p of x, q of x. This is the function that we're given. You see, right? And then the condition says this. Let me wait for it to load. The condition says that if the degree, let's look at this. The q of x is our denominator. You see, right? If the degree of the denominator is greater than the degree of the numerator, so this is what we'll be checking always. Then if this is the case, then we can decompose. So what we'll be doing, we'll be decomposing. You see, right? If the degree of the denominator is greater than the degree of the numerator, then we can decompose. So let's check that. How do we check the degree? The degree, we are talking about the exponent of x in this case. If we check the denominator, the exponent of x, if I try to expand this, I'm going to have 1. And remember, 1 can also be the same as x to the 0. So let me just say x. So this is like this: x to the 0, x squared plus x. So the highest degree of the denominator is 2. So if I say deg of q, that will be 2, and deg of p will be 0. There's degree 0 there. So since the degree of the denominator is greater than the degree of the numerator, we are allowed to decompose. So this is what we must keep in our mind. You see, right? We'll be allowed to decompose. So now I'm going to decompose this function. When you decompose it, you're going to take your p of x over q of x. Our p of x over q of x in this case, it's just 1 over x plus 1. You see, right? Then I say this will be equal to, since this is true, the second question which you would ask yourself is, can this function be factorized? If you can be able to factorize this function, it means that now I'm going to separate the denominator into, I say, remember the numerator, I'm just going to say, give them like this. If this is just x, not x squared, not, you see, such things, right? If it's just x to the 1, I'm going to say a over x. Let me try to wipe my screen. I think it's oily. So, and this I'm going to say a over x plus b over x plus 1. As long as each of these, after factorizing them, has degree of 1. You see, right now? As long as each of these has a degree of 1, then I'm just going to say a over b over. You see, right? Now this is called decomposing. Now when I'm decomposing this, the next aim for us to do here is to find a and b. You see, right? So I'm going to multiply both sides by this. If I multiply both sides by that, this will imply that 1 is equal to, here the x will cancel out. I'll have x plus 1 plus, here I'll have x, because the x plus 1 will cancel out. Yes, right? And then I'm going to simplify. This is going to be ax plus a plus bx. And then let's see. It means that from here I can say this side is a plus b, x outside, plus a. So if we check here, this is a plus b is equal to x. If we check on this side here, for what we need to know here is that since I've simplified this in detail, for me not to use the method of you remember you can use many methods as you like, right? So for me not to use that method of, so I'm gonna use both of them. If I don't want to use the method of for saying for x equals to 0, x equals to minus 1, I can easily write this one in this manner. I can say this is 0 x plus 1. So I'm trying to copy this standard. You see, I'm writing it in this, what we call a polynomial form. You see, right? So I see that this is in the same family as this one, meaning that I can equate them. And this one is in the same family as this one, meaning I can equate them. So it means that our a is equal to 1, and our a plus b is equal to 0. Since a is 1, it means that b will be equal to minus 1. If I plug 1 here and then I take 1 to the other side, I'll get b to be equal to minus 1. You see, right? Then after getting this, now we can check there what is our a, what is our b, right? I think I've typed them here. We can check what is our a, what is our b. So you check, you see that if you use this method of for x equals to 0, for x equals to minus 1, you're getting your a to be equals to 1, then you get your b to be equals to minus 1. You see, right? Now let me explain this method also. So I'm going to be explaining both. Now when I come to, if I want to use the alternative method, I can come and say from here, let me say 1 is equal to, I'll just write over here, x plus 1 plus bx. Remember, if we take this equated to 0, you say, right, if I take x plus 1, I equate it to 0, I'm going to get that x is equal to 0 or x is equal to minus 1. You say, right? Now I come and say for x equals to 0, if x becomes a 0, I'm going to get that 1 is equal to a. I'll just substitute 0 here, substitute 0 here. So those will go. You say, right now. And for x equals to minus 1, I'll have 1 equals to a minus 1 plus 1 plus b minus 1. This will go. So I'll be left with 1 equals to minus b, which this implies that b is equal to minus 1. Both methods, they're going to give you the correct solution. You say, right? So it's up to you which one you use. So after getting to this point, we're going to go back to our original equation. Our original question, we see that we had the integral of 1 over x plus 1 over x plus 1 dx, right? So I'm going to come and have that. This will imply that 1 over x plus 1 dx is equal to the integral of, remember this was a over x plus b over x plus 1. So you should keep this, and if it was like this, you keep it like that. Make sure, right? Remember your decomposition was like that. Now, and we know that our a is 1. And we know that our b is minus 1. So I'm just going to say minus 1 over x plus 1 dx. And then I separated them. In other words, I'm distributing the dx and the integral sign. Now, we ask ourselves this. Remember this one, whenever it becomes x plus something or 2x plus something in the denominator, you must ask yourself this question. If I take this and derive it, am I going to get 1? If you get 1, then you are fine. You don't have to think about anything else, right? So if I get 1, I'm just going to say ln of that. You say, right, ne? So I get 1 there in the denominator. So I'm just going to say ln of that. But if I was getting 2 or something, it means that I'll have to use u substitution here. Or if I get negative 1 or something, I'm going to have to use u substitution. You say, right? Now, since I get 1, when I derive that denominator, I can just easily say this. Now, this is not complete. We're going to say this is ln using the log properties. Ln of x over x plus 1 plus c. I'm sure we say this. Any question on this? Make sure that you open your mic if you have a question, because I can't see the comment section. Any question on this? And these ones, make sure that you always keep use absolute values here, right? Don't use things like x, open brackets. These ones, they have a meaning, so make sure you use absolute values. These two have different meanings. Absolute value says that we don't know what the outcome, whether it will be negative or positive, or we don't know what is the restriction of x. So we're trying to make sure that everything that happens or any value that we're given of x should remain positive, because we know the ln. You said, right now, if we put the negative inside the ln, we're going to have a problem. So make sure you keep that. Those are absolute values. Any question, guys? If no question, means that we're good, right? We can go to the second question. So let's look at the second question. Now, the second question that we're given, we have the integral of 2 over x squared minus 4. So just gonna write this 2 over x squared minus 4 dx. Remember I said that this is the same thing as having the integral of p of x over q of x. And I said that if the degree of q is greater than the degree of p, then we can decompose. We are allowed to decompose. You see right now? Then if that was not the case, it means that we would have to use long division. If we don't get this, if we get the opposite of this, we'll have to use long division. You see, right? So you must always keep in mind that. So we are going to say this. We say that this indeed we are allowed to decompose. It means that the next question that you ask yourself, remember I said that you need to ask yourself if the denominator can be factorized. So can we be able to factorize the denominator? Let's check that. We know that 2, this is the same as 2x minus 4, which is equal to 2 over x minus 2x plus 2. You see, right? So we're able to factorize this, meaning that we can now write this in the form of a over x minus 2. Remember I said that as long as here the degree is 1, you're just gonna say x. You see, right? So it doesn't matter here which one you start with. You can start with n. Now we have this, so it means that
I have a question.
Yes,
I'm sorry to disrupt you, but
yes.
Either or when you choose between x minus 2 and x plus 2, it doesn't make any difference.
Yeah, it won't make any difference.
So the values of a and b can interchange.
Yeah, they can interchange.
Okay, thank you.
Yeah, thank you. So, in other words, it doesn't matter what. Let's say someone decides to say this is equal to, let's say they say a over x plus 2, b over x minus 2. The people who say this, they're going to get, unless if the answers here are the same, but usually their signs are different. You remember, sometimes these are the same, but their signs are different, right? So here's what's gonna happen. If the one who's here, if you found a to be 1 and b to be minus 1, this one here is gonna find a to be minus 1 and b to be 1. At the end, you're going to swap with these two, because the one of negative, you don't want it to be here. You see, right, Nick? So at the end, you'll get the same answer or same solution. You'll see with that. We can even try here. We can even try to do such. So let's work on this two, right? Let's work on this two. If I multiply both sides by this, we're going to get 2 here, which is equal to the x minus 2 will be cancelled. We have x plus 2. Here the x plus 2 will be cancelled. We'll have x minus 2. So I said that, you remember, we can write this as a polynomial, right? We can say, first, before I write it as a polynomial, let's try to factorize this side. Let's try to simplify this side. And then we say this is, then I can write this as a polynomial to accommodate this. This one is the degree of, highest degree is x. It's 1 here. So we're just going to say 0x plus 2. And this is a plus b x plus 2a. Is it minus? Yeah, minus 2b. right? So if we check, this is in the same family as this one, so we can equate them. And also this one is in the same family as this one, so we can equate them. So we are going to say, or here I can even factor out the 2 here if I want to simplify things, but it's gonna make things a little bit mess. Let's just keep it like this, because you will need to factor out the negative. So from here I can say a plus b is equals to 0, and I say that 2 is equals to 2a minus 2b, and here we say that a is equals to minus b. So I come here and substitute minus b here on a, and get minus 2b minus 2b minus 4b, which means that b is equal to minus 1 over 2, which this is equals to, but it's fine. If b is equal to minus 1 over 2, it means that a will be equal to 1 over 2. You see, right? So I told you that whatever you get, mostly the answers are the same. You see, you get the same thing. The difference is the sign in most cases. I'm sure we can see this. If we check again, I said that we have the integral of 2 over x squared minus 4, and I said that we're just gonna look at which one is p of x, which one is q of x, and if the degree of the denominator is greater than the degree of the numerator, it means that we can decompose, right? So we did decompose. So, and we know that the integral of 2 over let's say this, we had this from the beginning, x squared minus 4 dx. In this case now it will be equal to a over, it was what? It was x minus 2. So we must make sure we put the correct one here. X minus 2 b over x plus 2 dx. This will be equal to, our a is positive 1 over 2. And then our b is negative 1 over 2. So we're going to factor out the 1 over 2, 1 over x minus 2 over x plus 2 dx. Then this will just be 1 over 2. Then we distribute these. So remember I said that as long as when you take this and derive it and you get 1, it means that you can easily come and say this is equal to ln of x minus 2. As long as when you integrate, when you derive this, you get 1, the denominator. You see, right? Also, when I derive this, I get 1. So I can easily say the ln of x plus 2. You see, right? Then I add c outside. Let's add it outside so that it doesn't complicate things. Then we use those rules here. We say x minus 2 over x plus 2 plus c. Then this will be the correct solution. Are we fine, guys? Any question? So I'm sure we see that that's how the solution is going to be. So now let's go back and check. If you check, this is what we got, right? We got our a to be 1 over 2, b to be minus 1 over 2. Just because I said a over x minus 2 plus b over x plus 2. But if I had swapped these denominators, my a and b would have swapped their values also. You said it. But at the end, the solution will still be the same. So the solution won't differ. You said it. Now let's look at this one. We're given the integral of 3x plus 1 over x minus 1. So if we look at this, the integral of it's 3x plus 1, right? Oops. If we check here, remember I said that this is the same thing as the integral of p of x all over q of x dx. And if we check here, the degree of q will be equals to 2, because if I multiply this, the highest degree will be 2, x squared, right? Which is greater than the degree of p, because the degree of p is 1. 3 to x to the 1. You say right now. So it means that I can decompose. Hence I can decompose, right? So now, since we can decompose and already the denominator is factorized, here's what you're going to do, right? You're going to say that 3x plus 1 over x minus 1 is equals to a over x plus b over x minus 1. We're going to ignore anything that is in the numerator. We don't care what's in the numerator, as long as this condition is met and the denominator can be factorized. So we ignore everything there. So you are going to solve for a, you solve for b. So I included this question because I saw a potential on that numerator that we would need to look at, but I'm not going to solve this one, because if you check, it is not that different from number 1. I just changed the negative here, then added plus 3x here. You see right now? So it's not going to differ that much. So you should make sure that I'm just going to leave it like here. Then I'll say try. Is there any question?
Sir,
Yes?
can you please repeat the part of you saying we are ignoring the coefficient of x?
Yeah, we're going to ignore this numerator.
Why?
The partial fraction does not talk anything about numerator. It only checks this condition. We don't care what's in the numerator. We only focus on the denominator. It's like we are trying to look for. Remember, this numerator is generated by multiplying this and adding them. You see, right?
Okay.
So here, yeah, we're trying to break it down to know what was there before it got simplified. Yeah, so let's move to a different one. Yeah, also this one is a bit similar to number 1, if you can check. Already it's factorized and the degree of the denominator is greater than of the numerator. So this one is also similar. You can look at it in that manner. So it doesn't matter which method you use. You can use this method or the one of polynomial. So it's up to you. Then already I showed you how to find the integral if it's like this. I said that if you're just gonna check the denominator. If you derive the denominator, if you get 1 after deriving it, it means that you can just come and write ln of that. You say right, ln of that. And then also if you derive this denominator, you get 1, it means that you can just write ln of this. Yeah. So let's look at a different one. Also this one is similar. This one is similar to number 3. As I said, you're just going to ignore the numerator. The denominators are the same. Just factorize that and ignore the numerator. So when you decompose, you see you ignore the numerator, but when you find your a and b, you're just going to multiply both sides by this denominator. Multiply both sides by the denominator. Like that. Now, where can I? Yeah. Now we have this one. I want to do something which is different. We have the integral of x squared minus 4x plus 4. So let's say they give you an integral like this. All right. Initially, we can tell with this one, it's simple to tell that the integral of, the degree of the denominator is higher than the degree of the numerator. This one is easy to tell, right? Now, we are going to say, let's check. And the question said 1 over x squared minus 4x plus 4 dx. So if we check this, right, we're given this question and they say we have the integral of x squared minus 4x plus 4. Who can tell me, what do you think we can do here? Anyone with a clue of how do you think you could approach this question?
I think you can try completing the square.
We can complete the square, right? Yeah. First, the first suggestion is to complete the square. Another one. Is there another approach that someone else would use? So, is there another approach that any other could use? You can remember, guys, we do come across different types of approaches, right? So, I'm not gonna limit you. So is there any other that we can think of?
Factorize the denominator. The denominator.
Someone is saying we can factorize the denominator. Yeah, and then I'm glad you say that. Now, we have two methods that we can use here, right? We can complete the square, we can factorize the denominator. So, both they are correct. So, if we factorize, how are we going to factorize this? You should always make sure that you know all the possible approach that you can use on a problem set, right? How are we going to factorize this?
Difference of two squares, x minus 2, x minus 2.
X minus 2, x minus 2. So they're saying x minus 2, x minus 2, right? So meaning, here's what you're gonna do, right? So once you're able to factorize this, so this is simple to factorize. If you're having a problem with factorization, guys, once you have a quadratic equation, you can use the quadratic formula to check your factors, right? Within the quadratic formula, you're going to get that x is equals to 2 for both of them. So already tells you that this is x minus 2, right? And x minus 2 is the same thing as what? X minus 2 all squared. So we cannot use this. You said, right? We should make sure if they're the same, should make sure that you put them as squared. You say right, ne? Now let's go to complete the square. Let's go to completing the square. How are we going to complete the square?
You add half the coefficient of x.
You're just gonna add it and subtract it, right? it's like you're gonna add it as a 0. You agree there, right, ne?
Yes.
Yeah.
Yes.
So what you're going to do, what they're saying here, guys, if you have x squared minus 4x plus 4, you're just gonna pick your b. Remember, it's the one which has which has the x to the 1. You see, right? It's the coefficient of x. You're gonna take that. You come here and say x squared. So what you're going to have, you're just gonna have x squared. Then you have minus 4x. And then you're gonna come and do this and say minus 4 over 2 squared plus minus 4 over 2 squared. Is it like this? Guys?
Yeah.
So you're saying it's like this, right? Then I add that 4 of mine there. So am I going to add my 4 there? Is that fine, right? Now, if you have this, so what are you going to get here inside?
4 minus 4.
No, let's focus on here first. You get what inside here?
Positive 4.
For negative. Now I want inside the brackets only for now. You get minus 2 squared. Inside it's minus 2, isn't it? What I'm saying is, what do you get inside here? Let's focus on that first, then we'll come back to that. Minus 2, right? Like this, right? If you check here, this one will give us a 0 if I expand it. Do you agree with me there? And it will take us back to the original one. Must you see this, right, ne?
Yes.
Yeah, so it means that we're just going to ignore everything. We say this all squared. You say, right? So we're just gonna pick any of these. So in initial, but there are many ways you can just myself. I try by all means to summarize the completing the square. But if you want us to discuss completing the square, we can also do that. We try to find more problems which require completing the square, and then we'll see how do we go around them, right? So let's say this, or let's say this. Let's say for those who don't understand how to complete the square, let's look at these examples. So I'm just gonna pick a random examples. For an example, let's say maybe we have x squared plus 4x minus 5. So what you can do, mostly what you can do here, how they used to teach us completing the square in high school, is you can leave the ones which have x only on the left hand side. You leave these ones, you take 5 to the other side. Then on both sides, you are going to add this. You remember your b is 4. So you're just going to add it in this format. You're going to say plus 4 over 2 all squared, which is equals to 5 plus 4 over 2 all squared. You said that you're just going to add that b both sides. And then you're going to have x squared plus 4x plus 2 to the 2, which is equals to 5 plus 2 to the 2. Do we see this? So it means that our solution lies here. We're just going to say that the solution is x squared, not x squared. We take the inside of that all squared. You see, right? So that will be the solution to this one. Do you see that? Now, if you check here, if I take this to the other side, it's gonna take us back to this question. You see, right? So now let's look at another example. Now, let's say now we have this. We can have 2x. Sometimes they change, right? They can even give you something like this. Remember, I'm gonna take the one which does not have x to the other side, which is this. And what is our b here? It's minus 12. So I'm just going to say this. Both sides I'm going to add minus 12 over 2 squared minus 12 over 2 all squared. Right? And then this will just be 2x squared minus 12x plus this will just be, this is minus 6 squared, 7 plus minus 6 squared. Do you see this? Now if we check this, right, or if we wanted, we could have easily factored out the 2 here. It would have been simple, much simpler that way, right? You can easily factor out the 2. Or let me see this. I just saw this now that the 2 can be factorized, not to complicate things. But if it was not going to be factorized, it means that you're going to try to change this, everything to be inside the square, the squared. So it means that you're going to write it like this. You say, right? But since it can be factorized, let me try to factorize it. The 2 can be factorized. X squared minus 6x, yeah, which is equals to 7. You see, right? So when I add both sides, I'm just gonna add this. So let me say this. So when I add both sides, I'm just gonna simplify it. Let me erase this. Since I factored out a 2, so let's come here and say this. Then we'll decide ourselves, right? Let's see. We have minus 6. If we check this minus 6, right? This is our b in this case, inside here. So if I add it here, let's say I decide to take minus 6 here. If I factored out the 2 there, I'm going to get minus 6x. Then I add what here? Minus 6 over 2 squared. You say, right? Do you agree with me here? Now, how was I going to edit this side? Who can tell me how was I going to edit this side? Since you see that there's a 2 here, when you edit this side, you're going to edit with that 2. You multiply outside by 2, so it's like minus 6 over 2 squared. So this is something that mostly you won't discuss, right? Or they won't show you something like this. But then it's another way of completing the square. Such questions where they come with coefficients, where the x squared is a coefficient and it can be factored out. You say, right? Now, this would be 2. If we try to simplify things at the end, you'll realize that it will take us back to the same solution or the same equation as before. Yeah, if you check, if you multiply this and you take this to the other side, they're going to cancel. You see that, right? So you should always make sure they're correct. So when you check this side, what you would get, I said that you're only going to focus on the inside. So this would just be x minus 3 all squared. You say, right? Is it fine? So I think I can stop here. I've looked at 2 different types of completing the square. So you won't be shocked when we complete the square like this next time, right? So, well, let me just do this. Just gonna screenshot these so I can send them there. Those who are interested in seeing them, or you can just look at them in the recording, right? Because I'm going to upload the recording after here. Yeah, then let's redo this completing the square, since now you have seen those who didn't or those who had forgotten, right? Now we have x squared minus 4x plus 4. Since now we can't take this 4 to the other side, we're just gonna add and subtract, right? We're just gonna do this. We're just gonna add the minus 4 over 2 squared and subtract it. Minus 2 squared minus 2 squared. So remember I said that we are only interested in these two, right? X minus 2 squared. So that's what we get when we complete the square. So this is going to be the integral of, here was 1 over x squared minus 4x plus 4 dx is equal to the integral of 1 over x minus 2 all squared. Is that right? And the degree of the denominator, we know that it's higher than the degree of the numerator. So we're just going to come and say this. So if I have this, if I want to decompose now, so check the difference now. Now everything is all to the 2. You see, right? So when you decompose, you are going to decompose from degree of 1 up until degree of 2. So here's how you're going to do it, right? So when you decompose from that, you're just going to come and say, yeah, you're allowed to come and say a over x minus 2 plus b over x minus 2 to the 2. So you decompose from 1 up until the number you have there. You say, right? So just like that. As long as the degree of this x is 1, this one will remain a constant, If it was a 2, this will just be some difference there. You say, right? But for now, let's focus on these ones of 1. So what we do from now on, we solve for a and b. We're going to multiply by this both sides. Here we get 1. This one of these will cancel. You have x minus 2 plus b. Yeah, this will entirely cancel. Now from here, we're going to simplify this side. So I said that we can easily write this in polynomial form. Then this will just be ax minus 2a plus b. So we can equate these two because they're of the same family, and also equate this because they're of the same family. So we know that easily here a is equal to 0. And since a is equal to 0, we know that 1 is equal to minus 2a plus b. And if a is 0, it means that b is equal to 1. You say, right? Now, since we say this, guys, you can't be asking who's the president now while we're having a session. Someone commented in the group, Boots, who's the president now. Let's focus on what we were doing currently, guys. So now we have our a as 0, our b is 1. So it means that,
Sir,
yes?
can you please go back to the part where we're equating 1 over x minus 2 all squared equals to a plus b, right?
Yeah, this part. This one.
Yeah. Like, can you please simplify it and explain what you're simplifying it?
Oh, I was saying that we multiply by this denominator both sides. This one. You say, right?
Yes.
So when I multiply this side, it's going to cancel or be left with 1, right?
Uh-huh.
Then when I multiply here, only one of it will cancel because there are two. You see, then I'll be left with 1. You see, then when it comes here, it will entirely cancel.
Oh, yeah.
Yeah. Then from there, you can use either this method or the other one. When you use the other one, it means that you will say, well, for x equals to 2. You say, right?
Yeah.
Yeah. Then you can use both methods. Is it fine?
Yes, it's fine.
Yeah, thank you. We have x minus 2 plus over x minus 2 squared dx. So we'll be left with this only, which is what we had from the beginning. Do you agree with me? You see that if we do things in this way, it's going to take us back to this portion. Do you agree with me there? Guys, do you agree with me there?
Yes.
Yeah. So if it takes us back to this portion, it shows us that initially this question required us to just come and use the substitution. So it means that initially we could have just come and say let u be equal to x minus 2. Then our du is going to be equal to dx. Then we say that this is the integral of 1 over u squared du, which this will just be the integral of u minus 2 du, which is equal to minus 2 plus 1 minus 2 plus 1 plus c, which is equal to minus u over 1 plus c. This is going to be 1 over u plus c. And what is our u? X minus 2. You see, right? Meaning that we could have easily solved the question like this, but the aim was not for us to easily solve it. The aim was for us to be able to, how did I find this negative here? Yeah, this is supposed to be negative. Yeah, the aim was for us to know how to do completing the square. So I couldn't find most of these questions where I could complete the square like this. But since you see, how do you complete the square or factorize? This one allowed both. It allowed us to factorize and complete the square. So you can use any method. But then we realized that if they had given you this question, it would be simple for you to just solve it in this way. And you get your marks. You say right, ne? So now let's look at another question. Now we have this one. We have the integral of 2x plus 1 over x minus 1 x plus 1 all squared. So we have discussed most of these. Now we are combining them. Remember the first part and also this one. So if we check, the degree of the denominator here is 3. Because this one here will give us x squared. This one of x plus 1 all squared will give us a squared. Then times this x here will get x to the 3. So it's greater than of the numerator, right? It means that we can decompose. When we decompose, already I've shown you how to decompose this one. Let me just use a pen. I've shown you how to decompose this one. I've shown you that when you are going to decompose x plus 1 squared, you are going to say a over, you are going to decompose it from 1 up until what you have. So it ends at 2, which is this part. Then this one is separately. That's how we put it like that. So we're just going to start with that one. This one will say B. This one will say C. I'm sure we'll say this. So is it fine, guys? So if you see this, it's going to be simple when we apply this technique, right? Now, nextly, what you're going to do, you're going to simplify both sides. So I'm not going to simplify this one. I'm going to leave it up to you to try and simplify, since the most important part here is decomposing. How, when do you know how to decompose and so on? But simplifying is just basic methods which you've been learning from high school, right, primary and so on. So you're going to simplify there. Then you tell me what you get, your A, B, C, and are they the same here, right? Now let's look at another problem, because I think we're left with 1 minute now for us to end the session. Then I'm gonna, so I want you guys to go look at this. Then you look at the problems. It means that our next session, because we couldn't look at some problems, we're going to continue to look at the problems. And then we look at the trig for the inverse trig functions. So for now, for sure, you do have a clue on what's happening here, on how to approach these questions. So let me see. I think I have to also, let me check if on the problem side, the type of a question I'm looking for is not there. I want to give you guys a question where the degree of the numerator is higher than the degree of the denominator, where you have to apply a long division. So I think I'm going to give you such questions, right? Because I think I didn't include them. So, yeah.